Today we're solving problem 19 from the AMZ 10A of 2021. A disk of radius 1 rolls all the way around the inside of a square of side length S is greater than 4 and sweeps out a region of area A. A second disk of radius 1 rolls all the way around the outside of the same square and sweeps out a region of area 2A. The value of S can be written as A plus B pi over C, where A, B, and C are positive integers, and B and C are relatively prime. What is A plus B plus C? So this is what it's going to look like. This is the square they're talking about with a side length of S. Now S, it says, can be expressed as S is equal to A plus B pi over C. And S is greater than 4. We also know that these two circles are exactly the same. So this is let's call this the center. We also know the radius. The radius is 1. And so it basically, the first circle moves around the square in this area. So, and we have to call this, and they call this area A. Now we can find this area. Okay, so we can cut it up. So we cut it up like so. And then there's going to be, in the end, there's always going to be these 4 quarter circles here. Now, we know that the radius is 1. This is the radius. Well, basically, we can construct the circle on one of these. Since the circle's the same, there's 4 of them, and each of them is a fourth of it. We can find the area of all these added up. That's the easiest way to find that one. So, the area of the circle is, I'll just write A. This is equal to the area of the circle, one of the circles, because it's all these 4 corners. This is just pi, because the radius is 1. Well, now we can sort of split it up. So we just draw some lines and then find the area of those lines. Okay, so let's start with this big square at the back. Well, we know that the height is 2 because we can construct the circle. The radius is 1. That means the diameter is 2. Now, this length is a bit more confusing, but the side length is S. These radiuses are 1. This is 1, and this is 1. Therefore, this is S minus 2 because you're subtracting these 2. Okay, so this is pi plus those 2. This is going to be, well, let's see. This is going to be 2 times S minus 2. But then again, we want to make this the easiest way possible, and there's another one here. I don't know why I drew this lines, but there's another one here. So we have to multiply by 2 again. Okay. Now we want to find the length of these squares. Of these. Well, how can we do that? Well, this length, well, let's start with the length. The length is 1 because this is the radius here. Now the height, this is still S minus 2 because the radiuses are 1 here, 1 here. So you subtract 2 from the total side length of S. Now the area is going to be S plus 2 times S minus 2 times 1. That's just 1. But now we have to multiply by 2 again times 2 because there's 2 of them. Now we want to find the area of this inner square. That's a bit more challenging, but I think we can do that. So we want the height first. Well, we can construct one of these circles. The diameter is 2. So there's two diameter of 2's, so this is going to be s minus 4. Now, that's the height. Now, we want the length. Well, the length is still 1 because there's this half circle here that corresponds with this. The radius is 1. So this is s minus 4 times 1. And now, well, there's still the second one, so we multiply by 2. So now we just multiply everything out. This is pi plus 4s minus 8 plus 2s minus 4 plus 2s minus 8. Now we can just solve with this. This is equal to pi plus 8s minus 20. So we have our first formula. A is equal to pi plus 8s minus 20. And our second formula is for A is going to be the area of this divided by 2. Now we're going to calculate the area of this outer area, I guess. Well, we can do the same thing. We can break it up here. Well, when we break it up like this, we have 4 segments of equal size. We also notice that the length of this segment is s, or the side length of the square. Now, we can also construct another circle. If we construct a circle like this, well, we also know the height. This diameter is 2 because the radius is 1. Therefore, if the diameter is 2 here and it corresponds to the height must be 2. So now there's 4 of these possible rectangles. So the second equation is going to be 2a is equal to 4 times 2s plus, well, these corners. And the reason why it's 2a is because we're given it's 2a. Okay, it says that the second disk of radius 1 rolls all the way around the outside of the same square and sweeps out a region of area 2a. That's what the problem says. Now, we can also use the same strategy here. We want to add up all 4 of these corners. Well, now, when we form these together, we can also know the radius. So let's just draw a circle like this. That's the bad circle. But when we draw a circle, it's split into 4 corners, like these 4 corners here. Now, well, this is 2 because, well, 2 is the diameter of the circle. This is 1/4 of it. We know the radius is 2 here. Okay, so we can find the area of all of these added up together since they form one big circle. So we can just use the formula. This is 4 times pi. 2a is equal to 8s plus 4 pi. We have 2a, we can divide by 2. A is equal to 4s plus 2 pi. Now, 1 and 2, equations 1 and 2, they're both descriptions of A. They're just different. So we want to find what S is. We can do that by setting them equal. 4s plus 2 pi is equal to pi plus 8s minus 20. Remember, we want the value of S. So we can just move everything to one side. Well, we want S on one side, so let's do that. This becomes, so pi plus 20 is equal to 4s. When you divide by 4, 5 plus pi over 4 is s. And I did that because that's the order of s. Now, we know what the values of A, B, and C are. This is 5, This is 1 times x, and this is 4. So 5 plus 1 plus 4 will give us our answer of 10. So we have done this problem.